Hello everyone, welcome to another session. In this session we are going to talk about differentiation. Previously we solved many limit questions, and after this it's better to study differentiation. We directly went to section 3.2. After we finish derivatives, differentiation, then we can go back to section 3.1 using some simple ideas that you learn from this section. The section 3.1 will be way easier. Let's begin with differentiation rules. Before we start, when we say differentiation, on where we say derivatives, it's the same thing. Differentiation and derivatives are the same thing. And we have these symbols for them. We use y prime sometimes. That's derivative or differentiation. Sometimes we write dy over dx. This is also differentiation. Or sometimes we write f prime or g prime of x. These three things are all the same, and they all represent derivatives. And another thing is differentiation and derivatives are also the same thing. There is a table of basic derivatives, and each one of these could be solved using one of the differentiation rules that we are going to study them. Then let's begin here. Rule number 1. If fx is equal to c, if fx is a constant, the derivative of it is 0. We have examples. A, fx equal to 3. What's the derivative of it? The derivative is 0 because 3 is a constant. B, y equal to pi plus 1. Pi is a number. Pi plus 1 is number. Then derivative of numbers is 0. If you notice here in part A we wrote f prime of x. Here we wrote y prime. There's no difference between them. They just both represent derivatives. Rule number 2 is with x when it has power. If x has power, the power goes to the front, power minus 1. That's the idea. If there is a coefficient in front of x, when the power goes to the front, it will be multiplied. Simple. We have examples as well. A, fx equal to x power 4. Then f prime of x. The question asked in terms of f, so we answered in terms of f prime. The answer is power, which is 4, goes to the front. 4x. Power minus 1. It was x power 4, now it's x power 3. This is the derivative. This example, fx equal to 3x power 5 plus 2. For plus and minus, it's not a big deal. We do each derivative separately. Now, derivative of 3x power 5. Leave the 3 as it is. 3 times x power 5. 5 goes to the front. X 5 minus 1, 4. Then later when we multiply 3 times 5, it will be 15. It's times between them. Plus, derivative of constant, in rule 1 we learned that it's equal to 0. So if we simplify this, the derivative, it's asked in terms of f. So f prime of x after simplification is equal to 15x power 4. Plus 0 is nothing, so this is the derivative. Rule number 3 is for root, square root. Square root of x, the rule is like this. 2 times the square root goes down. Derivative of what's inside the square root goes up. Here inside the square root we have x. Derivative of x is 1. 1 goes up. Example. Find the derivative. Let's do this. Whatever root we have, 2 times the square root. What should we write up? Derivative of what's inside the square root. What's the derivative of 2x plus 1? You should know that by now. Derivative of 2x plus 1. Derivative of 2x is 2. Derivative of this 1 is 0. We don't need to write 2 plus 0. It's just 2. We can simplify this. 2 cancels 2. The final answer is 1 over square root 2x plus 1. This is the final answer. F is 4x squared. As we said, f prime of x, it will be fraction, 2 times the square root. 2 times square root of 4x squared. And what should we write up is the derivative of inside. What's the derivative of 4x squared? 2 goes to the front. It will be multiplied with the 4. That will be 8x. There is simplification between 8 and 2. So this 4 under the square root also can go out. Then the 4, when the 4 goes out under the square root. In multiple choice questions, it's very important to not ignore questions when you do a step. Simplify until the answer is in the simplest terms. When the answer is in the simplest form, then it will look like one of the choices in the multiple choice questions. Now 4 can go out under square root, becomes 2. We already have a 2, it becomes 4. So we will have something like 8 over 4. 8 over 4 simplifies to 2, so only 2 remains up, 2x, and down is square root x squared. Then square root and x squared will be cancelled as well. So the final answer of this question is just 2. Now let's move on and see some other rules. Rule number 4. That's a very good rule. It's plus. It's not minus. If we have multiple functions together, like this, we have 3 functions together. Each one is like a different expression. We do the derivative of each one separately. Derivative has no problem with plus and minus, but with multiplication and division, we will have special rules to do their derivatives. Now, if we have 2 functions added, the derivative will be like the derivative of each one as they are. Now, let's do this example. We have 2x cubed plus 4x minus 1. To do the derivative, we do the derivative of each one separately and we put plus and minus accordingly between them. Now, what's the derivative of 2x cubed? The 3, which is the power, goes to the front. 3 times 2, 6. Power minus 1, it's x power 3. Power minus 1 becomes x power 2. Plus, derivative of 4x is 4. Derivative of 1 is 0. I don't need to write, so this is the answer. Here, we have another example. 4x squared, the derivative will be 8x. Power goes to the front. 2 times 4 is 8. Power minus 1, this is power 2. It becomes power 1. Plus, as it is, square root of x becomes 1 over 2 square root x. We just had this as a rule. Now we did the derivative of each one separately. This is the answer. So I'm saying that again, when you do derivatives, simplify the question until it's in the simplest form. Because in multiple choice questions, the choices are always either simplest or like one step before the simplest. We have another rule. If there is a constant, if there is a number multiplied by a function, when we do the derivative, we leave the number. We don't do anything to it. We just do the derivative of the function, then times the number that was before the function. Through examples, you can understand this better. Now, if we have 5x squared, okay, we leave the 5 as it is. X squared, the derivative of x squared is 2x. Now, this 2 and this 5 should be multiplied together. So the answer is 10x. Similarly, for this example, we have 4 times square root of 2x. Leave the 4 as it is, times square root of 2x becomes 2 square root of 2x times the derivative of inside. Derivative of inside is 2. Then there is a lot of simplification. 2 cancels 2. 4 remains up. So the answer is 4 over square root 2x. In the choices, they can even simplify this more by writing square root 2 alone, square root of x alone, and then simplify square root 2 by 4, it could be simplified more. Rule number 6 is product rule. Product rule is a very important rule. If we have two functions multiplied together, to find the derivative, we follow this rule. The rule is simple. It's like when we have two functions multiplied together, the derivative will be first as it is times derivative of second, plus second as it is times the derivative of first. If we switch them, it's fine because it's times and plus. It's fine if someone say derivative of second times the first function, or first derivative of first times second. It doesn't make a lot of difference. Here, the rule, first times derivative of second plus second times derivative of first, it works. Let's have an example. If we have multiplication, for multiplication, we cannot do derivative of each one separately. It's not like plus or minus. We should use the rule. The rule says, keep the first as it is, multiplied with the derivative of second. Let's do this. Keep the first as it is, 2x plus 1, times derivative of second. What's the derivative of x minus 1? X minus 1, it will be derivative of x, which is 1, minus derivative of 1, which is 0. Then first times derivative of second, it's like times 0. All right. Plus. This time we keep second as it is. It's x minus 1 times derivative of first. What's derivative of first? Derivative of 2x is 2. Derivative of 1 is 0. So derivative of first is just 2. Now let's simplify what we have. If we multiply 1 by anything, it stays the same. 2x plus 1. If we multiply 2 by x, it will be 2x. It's positive. This is also positive, so it's plus 2x. Nothing is random. 2 times negative 1 is negative 2. We can simplify this one more step. 2x plus 2x is 4x. Positive 1 minus 2 is negative 1. This is the final answer in simplest form. We have another example. X squared and a bracket, 3x minus 1. Since there is nothing between them, it means multiplication. When we have multiplication, we cannot directly do it. We need to use the product rule. Product rule says first times derivative of second plus second times derivative of first. Now let's do it. First times derivative of second. Derivative of 3x minus 1 is just 3. Plus. This time second, which is 3x minus 1, times derivative of first. Derivative of x squared is 2x. Now, if we simplify, 3 times x squared is 3x squared. 2x times 3x is positive 6x squared. 2x times negative 1 is minus 2x. 3x squared, 6x squared together could be simplified to 9x squared minus 2x. This is the simplest form. After the product rule, there is quotient rule, fraction rule, division rule. It has so many names. Quotient rule, which is more known as division rule or fraction. This rule is also one of the very important rules. Here, if you have a function divided by another function, like this is a function, it's divided by another function. All right, what we do, denominator power 2. This is the key. A lot of students do a very common mistake here, but let's avoid this mistake. Start always with denominator power 2. After you power 2 the denominator, Don't simplify it right away, only write to see if you are using the rule properly. Now, denominator power 2. Always write the denominator first. So we begin with the denominator. You write the denominator, power 2, then up, again write the denominator, times derivative of the numerator. Numerator means the part which is up, okay? This time, because it's minus between the two parts, order is important, order matters. If you switch these two, your answer will be wrong. And this is a very common mistake. Most of the students are doing this. So when you have quotient rule, when you have division or fraction, always start with this, write it as power 2. Then write it again up. Times what? Since this is not derivative, it's the same, then the other one, the partner, should be derivative. Times derivative of up, f prime. Then minus, since we've wrote derivative of f here, we write f as it is in the second part, after the minus, times derivative of denominator. Now, from the examples, we can understand this better. Here, fx equal to 3x plus 2 over x squared minus 1. Look at this. I have a fraction. Begin with denominator. X squared minus 1. Write it with power 2. Finish. Now, x squared minus 1. Write it again here with no change. All right. We wrote the denominator. We wrote the denominator power 2. Since we wrote the denominator as it is, the other part should be derivative. What's the derivative of 3x plus 2? Derivative of 3x is 3. Derivative of 2 is 0. Then we only write the 3. Finish. Minus. This time we write the numerator as it is, 3x plus 2, times the derivative of down. Down is what? It's x squared minus 1. Derivative of x squared is 2x. Derivative of x squared is 2x. This is the 2x. After this, we can multiply and simplify. Then we get the final answer simplified. Let's do this example. X squared plus 1 over 3x. All right. What we begin with, right, a very big fraction. Denominator, 3x, power 2. Write the denominator again, 3x. Multiply by derivative of up, x squared plus 1. If we find the derivative of it, it will be 2x. Then I write here 2x. Minus. For the division rule, it's minus between the two parts. Now, I write x squared plus 1. And this should be multiplied by derivative of down. Derivative of down is 3x. The derivative is just 3. Multiply by 3. All right. Let's simplify this. 3x times 2x is equal to 6x squared. Minus 3x. 3 times x squared is, with this minus, it will be minus 3x squared. There is another common mistake. This minus is for both. It makes the x squared negative and it makes the 1 negative. Now after I multiply them by the minus, they both become negative. Multiply them by 3, it will be 3x squared, negative 3x squared, minus 3. All over this 3x squared, we can write it as 9x. Bracket with power. Bracket with power can make so many questions, so many complicated questions easy. When a bracket has power, we don't need to expand, simplify, then do derivative. We can directly do the derivative. Then this rule is a very good rule. It makes so many questions easy. The idea of bracket with power is like this. If you have any bracket with power, power goes to the front. Bracket, inside the bracket, we don't change anything as it is. Then the power minus 1. After that, we multiply by the derivative of inside. This is the difference between a bracket with power and x with power. When we just have x, we don't do this step. But since we have bracket, we should multiply by derivative of inside. When you study differentiation or derivatives, always consider the derivative of inside. Derivative of inside is very important for brackets with powers, for composite functions, for trigonometrics. Then if you always ignore derivative of inside, most of the time the answer is not complete. Now let's do these two examples related to brackets with powers. The first one, 6x minus 5 all power 3. To do the derivative of this, then, as the rule said, power goes to the front, power minus 1. Now, it's power 3, the 3 goes to the front, and power minus 1. It was power 3, now it's power 2. Bracket as it is, always. Alright? Now, the step after power goes to the front, bracket as it is, power minus 1, we multiply by the derivative of inside. Inside only. We don't care about any power. Inside the bracket is 6x minus 5. What's the derivative of this? Derivative of 6x minus 5 is just 6. So here we write 6. Then the answer is complete. Here, fx equal to 4x squared minus x, all power 5. Then, since there is bracket with power, we use the rule of bracket with power. Power goes to the front, bracket as it is, power minus 1 times the derivative of inside. Derivative of inside, we don't care about the 5. This is the inside. What's the derivative of this? Derivative of 4x power 2 is 8x, minus derivative of x is 1. Then inside this bracket, we write 8x minus 1. This is the derivative of this function. We can simplify this. Rule number 9 is for ln. Ln, the idea of ln, whatever we have inside the ln goes down. Look at here. If fx is equal to ln x, anything we have inside the ln goes down as it is. Then what do we have up? It's the derivative of down. What's inside the ln goes down. Derivative of it goes up. Look at this one. This example, find dy by dx. Find dy by dx means find the derivative. Now let's find the derivative. Ln of 2x minus 3. The derivative, the question asked in the form of dy dx, so we answer in the form of dy dx. Although it doesn't change anything, it's only name. Ln, result is fraction, derivative of ln. Whatever is inside the ln goes down. 2x minus 3. 2x minus 3, 2x minus 3. It goes down. What's the derivative of this 2x minus 3? Derivative of 2x minus 3 is just 2. The 2 goes up. This is the derivative. Another example. We're going to use a property of ln, then we do the derivative. For this example, since inside the ln is fraction or division, this is a property of ln. If we have division, we can write it as minus. If you have ln a over b, it will be ln a up first minus ln b. But if you have minus inside ln, we cannot make this division. We can only make division inside ln minus. And if you have two different lns minus between them, we can make it one ln with division. All right? Don't confuse this property with ln of minus. If we have b minus a inside ln, this will not be division. This rule is not reversible. It's only one way. If you have division, it becomes minus. But if you have minus, it cannot be simplified. Don't mix this. Now let's go back to the question. we have division. I write as two different lens. Ln of 1 minus x minus ln of 4x plus 7. Now, I need to find the derivative of this. Then, since it's ln, use the idea of ln. What's inside the ln goes down, the derivative goes up. Then, if I want to find the derivative, dy dx, or this question is asked in the form of x, fx, we can answer as f prime x, it doesn't matter. Now, ln 1 minus x goes down. What's the derivative of 1 minus x? Derivative of 1 is 0. Derivative of x is 1. So it will be 0 minus 1. 0 minus 1 is negative 1. This minus stays as it is. Ln of 4x plus 7. 4x plus 7 goes down. Derivative of 4x plus 7 is 4. So the 4 goes up. Now, if you see this question in the exam, they will not give you the choices in this form. They'll make the two fractions 1. And to make the two fractions 1, because between them is minus, we need to find the common denominator. The common denominator has both denominators. 1 minus x, 4x plus 7. Both denominators together is the common denominator. Now we should multiply 4 by 1 minus x, and we should multiply 4x plus 7 by minus 1. 4x plus 7 times minus 1, it will be minus 4x minus 7, and this minus goes only with the 4. Now 1 minus x times negative 4, it will be negative 4 plus 4x. 1 times negative 4 is negative 4. Negative x times negative 4 is positive 4x. Then 4x cancels 4x. Negative 7 minus 4 is negative 11. The final answer is negative 11 over this denominator. Or sometimes in the multiple choices that even the denominator is not given like two brackets, it's given as a quadratic expression. We can expand this and simplify to see the final result. But the idea is here to find the derivative correctly, then the simplifying is okay, it's manageable. For trigonometrics, sine, cosine are very easy. Tan is a little bit not as easy as sine and cosine. All right. Derivative of sine is cosine. Derivative of cosine is minus sine. This is the difference. Derivative of sine is cosine, but derivative of cosine is minus sine. While derivative of tan x, the derivative of it is 1 over cosine squared x. Or tan x has another way. Tan x is tan squared x plus 1. Okay? There are some blank brackets. Now you might wonder why these brackets are there. These brackets are there for the derivative of inside. What's inside sine, cosine, or tan is angle. So the derivative of the angle should be also considered, and we multiply it after we find the derivative. So one general idea for all trigonometrics that always works is like derivative of the function times the derivative of inside. By derivative of the function, I mean when we have sine, derivative of sine is cosine. Then times the derivative of inside. When you have cosine, derivative of cosine is negative sine. What's inside the sine or cosine stays the same. After that, times the derivative of inside. Inside is angle. And tan, as we mentioned before, it has two possible answers. They are both correct. It depends on the multiple choices, which one to choose, which one to use. If you want to use this, you should have something related to cosine in the answers. If there is no any cosine, or if there is no any fraction in the answers, it's better to use the other way. Both ways are correct, both ways are working all the time. Now we have some examples. Don't forget these. we have some examples here. Find f prime of x. All right. What's the derivative of sine? Derivative of sine is cosine. Cosine. The 2x stays as it is. Then times the derivative of inside. What's the derivative of inside? What's the derivative of 2x? It's 2. So the final answer is 2 cosine 2x. This is the final answer. This could be also simplified using the trigonometric identities. This could be simplified as well. But it depends on the multiple choices. Do we need to simplify this furthermore? Or the choices are given like this? So this is where you make the decision to simplify it more or not. Another one, we have cosine of x power 2. Cosine of x power 2. Derivative of the function. The function is cosine. Derivative of cosine is negative sine. The angle stays the same for this part. After I did the derivative of the function, I should say times the derivative of inside. The derivative of x power 2 is 2x. So the answer is negative 2x sine x squared. What's between them? It's times. This x squared is the angle because it's different when the power is on the sine or when the power is on the x. Let's have another example about tan. All right. Tan. Example C. Find the derivative of tan 3x. To find derivative of tan, as we said, there are two ways of doing it. Both ways are correct. Both ways work. Now, using 1 over cosine squared. Okay. Here, whatever we have inside the tan goes inside the cosine as well. So the derivative in case 1, tan 3x. Tan 3x becomes 1 over cosine squared 3x. Always remember, times the derivative of inside. Times derivative of inside is 3. Then this simplifies to 3 over cosine 3x. Can this 3 cancel this 3? Of course no, because this 3 is angle. Angle is locked inside the cosine. It's locked, it cannot be simplified. This 3 is constant. If we had a 3 here, it could cancel this. But this 3 inside the cosine, it cannot be cancelled. Let's do case 2. Case 2, same question, tan 3x. Find derivative. Okay, the other rule was like tan squared of x plus 1. Again, don't forget times the derivative of inside. This will be tan squared of the same angle 3x plus 1. This plus 1 is in the rule. Then times the derivative of inside, which is 3. So this is the rule of tan. This is the end of this session. We almost discussed all the possible rules, all the important and necessary rules of differentiation. Thank you so much for watching. Stay tuned to see some extra exercises and to see the rest of the book. Bye.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە. بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن، ئێمە هەموو پێداویستەکانی قوتابخانەمان بۆ بەردەست کردوون بە بەرزترین کوالێتی و باشترین مەواد. لای ئێمە هەموو جۆرە مەلزەمەیەک بە کوالێتێکی بەرز و جوانترین شێواز دەست دەکەوێت. هەروەها هەموو پێداویستەکانی قوتابخانە بە هەرزانترین نرخ دەست دەکەوێت. لە فۆتۆکۆپی لاس چاپکردنی کتێب و بزنس کارت و وەسڵ بە کەمترین ماوە و جوانترین شێوە. هەروەها چاپکردنی فلێکس و لەزگە و تابلۆ و چاپکردنی نووسین لەسەر کوپ و تیشێرت بە بەرزترین کوالێتی. گەیاندنمان هەیە بۆ هەموو شار و شارۆچکەکانی کوردستان. بۆ دەستکەوتنی ئەم بەرهەمانە سەردانمان بکەن بەم ناونیشانە: هەولێر، دووسایدی بەحرکەی کۆن، بەرامبەر ئامادەی ژیاری نەحکومی. گروپی لاس بۆ فۆتۆکۆپی و پەراوگا.